Hello everyone, today we will be discussing the Kirchoff's voltage law, that is Kirchoff's also the second law, which is basically based on the conservation of energy. The statement for this law is the algebraic sum of all the voltages around any closed loop in a circuit is equal to 0, that is summation V is equal to 0. And just to describe this law, we have taken a very simple example here, which comprises of a voltage source and two resistances R1 and R2. I1 is the loop current and V1, V2 are the voltage drops across the resistances respectively. Now if we apply the KVL law, that is summation V is equal to 0, we will be writing V minus V1 minus V2 is equal to 0, which will be equal to V is equal to V1 plus V2, or we can also write it as minus V plus V1 plus V2 is equal to 0, that is also equal to V is equal to V1 plus V2. Now there is one more thing, that is the sign convention into it. While writing this loop equation, we will be using the sign convention here. So there are two sign conventions here. The one is if we are entering from the negative terminal and exiting from the positive terminal in the direction of current. Okay, in the direction of current, one convention is this, that we will be taking the polarity of the terminal from which we are leaving. Okay, like here we are entering from the negative terminal in the direction of current and leaving from the terminal positive. So we will be taking the battery voltage polarity is equal to positive, and the same is with the V1 and V2, because we are exiting from the negative terminals, so we will be taking their polarity as negative. Okay, this is the one sign convention based on which we have written the first equation, that is this one. And the second convention is just opposite to that. If like here we are taking the polarity of the exiting terminal as the polarity of that voltage drop, and into the second sign convention we will be taking the polarity of the entering terminal. Like here in this case, the entering terminal for the battery is negative, so we will be taking the polarity of battery as negative. And similarly for V1 and V2, the entering terminals are positives, so we will be taking their polarity as a positive. If we write the equation again using this sign convention, the equation will be like this. The second case, minus V plus V1 plus V2 is equal to 0, which will also result into the same equation, V is equal to V1 plus V2. So these are the two sign conventions which are used into the while writing the loop equations in KVL law, and both are right, both are correct, both can be used. Whichever you feel is the better one, you can use it. Both will result into the same answer. So this is the KVL's law, which is based on conservation of energy. The one thing which has to be taken care of here is that once we choose the one sign convention, we cannot use the another sign convention in the same equation. One sign convention has been chosen once, that has to be followed throughout the loop while writing the equation. That has to be taken care of into this. Okay, so this is KVL's law. Thank you so much. If you like our video, please do subscribe and share it. Thank you.